Hello, in this video I'm going to show you how to create a project using the LabVIEW FRC ball simulator and how to make it run and some of the tricks or whatever to get it to drive around. So the first thing we're going to do is we are going to go here to FRC and we are going to create a new RoboRio project. 2017 allows you to create a ball shooter simulator, and you want to type your team name in here. Just make sure you remember what team number you use because you'll need to put that in your driver station as well. We're here to show you all the files that will be generated from this project. You can give it a name. And we can give it a place where we want to store it. Or we'll use the default in this situation. And then we click Finish. LabVIEW will generate us a new simulator, ball shooting simulator. And once completed, you will have a simulated ball simulator project. If we open Robot Main, this is our front panel. As a product of the simulator, they add some extra indicators here to show score, shooter speed, and such. So let's run the simulator. So like with every RoboRio project, you must have the driver station open. So we're going to go over here and we're going to open our driver station. Give it permission to come online. And then we are going to go over to settings. And we are going to type in the team number that matches our project. We're not going to use the dashboard. We'll do dashboard in a different video. Okay, so you can see that I have my joystick plugged in. Let's do some joystick. So I'm going to turn the camera around here and bring my joystick up here into view. This is a Logitech controller, and if we go over here to our USB tab, it says that I have one game controller in there, the Logitech F310, and we can move axes up and down, left and right, and we can push our buttons A, B, X, Y, our trigger buttons. We also have trigger axes. It's a right trigger and our left trigger. One thing to note is there's a switch on the Logitech, and just make sure that I have it in the X position to get these same results. Not sure what the O position will do, but it doesn't work as well. Another thing, the start and the back buttons are also registered. And one buttons that a lot of people forget are there's actually the joystick has buttons. You can press down on the joystick, that's a button as well. The POV is this little dial here, up, down, left, right. You can also use that as a robot controller. And the button right here, this is your start button or your mode button, and if you push that, a little LED turns on, and what that does is that swaps the joystick here with the POV. And turn the mode back off, then the POV's back to this, and your joystick is back to being controlling by that item. Okay, so one thing to note is the numbers here, 0, 1, 2, 3, 4, 5. These are the indexes of the arrays when you, in LabVIEW, when you ask for the all the accesses using the joystick commands, you'll get an array, and if you want to know what axis each index is, it shows you here in the driver station. The buttons, the same thing. They don't label them here, however, but if I push the green button, you'll see that first one is, and that's actually button 0, button 1, button 2, button 3, button 2, and so on. So sometimes these are hard to remember, so we will create an enum and use that enum to help us remember the index of each of these buttons, and we'll show you that in following videos. Alright, I'm going to turn the webcam back around. And let's drive the simulator. So I'm going to go back to the driving tab, and we are going to start robot main. And here you will see our ball simulator. I'm going to expand it a little bit. Just get a little more view. There is a zoom follow button here. If you click on this and you zoom in, this camera will always follow the robot. And then we have side view, and we can also do driver view, and the follow button will also work in driver view. So I'm going to enable the robot, and then I'm going to show you the different axes we use. You can see as I move this axis forward, the robot will go forward. Axis 1. If I pull back on the stick, giving a positive axis, the robot goes backwards. And if I go x-axis fully right, we turn right, fully left, we turn left. And if we push the green button, it will shoot a ball. Okay, to stop the simulator, we will come here and either click close or click on the X. And you see we'll lose communication, and robot code will shut off, and we're back to coding. So let's take a look at the robot simulator code starting. If we go to begin, you can see we set up lots of different actuators and sensors. So we go back to the project. From any VI, you can get to the project by pressing Control Shift E, and it will jump right to your project. It will show you whatever VI you're in, and will take you to that VI in the project. One thing to note, if you're wondering what all the different actuators are on this simulator robot, they've created a README file. We open this README file up. you will see that it gives a listing here of what each of the motors is, what PWM connection each of the motors is connected to. And that PWM designation will help you know that PWM0 and PWM1 represent the motor, the drive motors. And if we go to our code here, you'll see here P uses PWM0 and PWM1 to set up the drive, and so on. Make sure that your joystick is using USB 0 corresponding to these numbers here. So this is the begin where we're setting up our shooter, our servo, agitators, all our different mechanisms that are on this robot. We're going to look at teleop just to see what things they do in teleop. Teleop, we get the references using these VIs to read them. You see, this is where we get all our joystick values, and then this is the array of all our axes. And if we want to get axis 0 and axis 1, so when you use this index array, always, if you don't put values here, which you really should, but if you don't put values here, it starts at 0, 1, 2, 3. So if we go to axis 0 and axis 1, you see that axis 0 represents the X value in an arcade drive, and axis 1 represents the Y value in the arcade drive. If we go back to our FRC driver station, this axis, axis 0, will be controlling the X-axis of our arcade drive, and axis 1 will control the the Y-axis of our arcade drive. Similarly here, we are pulling out this Boolean array. These are all our buttons, and since we didn't wire this, this is going to be button 0. Button 0 will take the shooter servo, and when you press it, the shooter servo will go to 0, and when it's false, the shooter servo goes to 85 degrees. And that button, you can see here is the first button. I'm going to push the green button. That's button 0. Assuming index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 buttons. And you can see that in this implementation of the default code, they don't pull off any other axes. They send data to the network tables, and they say the buttons to the network tables, but they only use the green button and these 3 axes. So this axis is the shooter motor drives. So if you were to use the 0, 1, 2, third axis, you could set the speed of the shooter. So let's see what our third axis, 0, 1, 2, 3. It's the right trigger. Left, right trigger here. So this will allow you to control speed. Alright, so let's see if that works. We're going to go back to our main. I'm going to hit Control Shift E to go to the project, and I'm going to open Robot Main, and I'm going to run Robot Main. And there's my simulator, and I have to go to my driver station and enable my robot. And I'm going to drive it. Set it right there, and I'm going to shoot a ball. Boom. Alright, and then it says if I pull down the right trigger, see how far that shot? Pull down the right trigger, it should speed up my ball shooter and shoot again. See if that doesn't shoot farther. Looks like it has a little more energy, maybe. Not too much farther. So let's debug this. So I'm gonna come back to Teleop. I'm gonna put a probe here. You see, there's a probe, and then as I pull my right trigger, nothing happens. On my left trigger, nothing happens. So let's put a probe here. Now if I pull my right trigger, I get change. Slide these over. So somewhere there's this shooter switch. Right. And when that shooter switch is true, let's probe that. Yes, the shooter switch is true. So it is using, according to the select case, we're going to use this data, which is 0.7. If the shooter switch was false, we would actually use this axis, which is my trigger axis. So let's see, how can we shut shooter switch off? I'm going to have to stop the program. And we're going to go back to robot main. Okay, we're going to continue looking here at Teleop. And we're going to bring our code in. And we saw that there's this network table that's looking at shooter switch. So I'm going to highlight shooter switch. And I'm going to copy it, Control C. And then I'm going to bring up my searcher. So I'm going to hit Control F. And I'm going to Control V. I'm going to paste it. And then I'm going to tell VI, I'm going to tell LabVIEW I want to find all instances, but I'm going to go to more options here and tell it only block diagram and labels. I don't want it to look for this in the front panel. Saves a little bit of time. And I'm going to click find. I'm going to skip any VIs that are password protected. You'll see that LabVIEW found it 3 places where this shooter switch exists. So in order to toggle through all these, it tells me if I just hit Control G to go forward or Control Shift G to go backwards. So I'm going to hit Control G, and you see it says shooter switch, but that's just a label. And you see right above it, I hit Control G again. This is where it's initialized and it is set to true. So if I set this to false, when I get to Teleop here, this value here will be false, so it will use this value to set the shooter, which is my speed control, which will be my right trigger. And then I'm going to hit Control G again just to say, make sure I found all of them and I understand what shooter switch is used for. Okay, so I'm going to bring up the robot main again. If I don't know where it is and I can't find it, I know I can find it from the project, so I'm going to hit Control Shift E to bring up, show me where this VI is in the project, and I know robot main is right down here. Open robot main, make sure driver station is open, and you're going to run. Opens up our simulator again, make some more space so it's easier to see. And we'll zoom in a little bit and see if we can't see. We'll go back to our driver station and we enable. And we see that maybe our wheels aren't spinning. Maybe zoom in a little better. These are our ball shooter wheels. And I'm going to pull the right trigger. And you see they are spinning. And I'm going to release the trigger, and it looks like it's... So with no ball spinning, I'm going to try and eject the ball, and it should not shoot. Yeah, it got stuck. And then I'm going to spin the wheels. Oh, and it looks like it's spinning them backwards. Eject the ball. It looks like it throws them right back into it. So we need to reverse those wheels. So we're going to stop simulator. And we're going to go back to teleop, and you'll see here, if you were using the shooter speed variable, you would negate this. So maybe we also need to negate it here, or take this negation away. So I'm going to insert numeric palette. I'm going to negate the value here as well. And I'm going to try it again. Run robot main. Have the simulator come up. Enable the robot. The wheels are turning. Maybe the wheels are turning in the same direction. And wheels on full blast, and eject the ball, and it's shot. Okay, looks like that fixed it. I'm going to zoom out here. Alright, so I'm going to bring the driver station up here so you can see what level I'm using my trigger at. So right now my trigger is at 0, and I'm going to try and set it about half speed and then shoot another ball. And that went pretty far. Hit the blue wall about halfway. So I'm going to go full speed, throw another ball. It looks like my showing here. Trigger full blast, and then fire the button. And that looks like it was a lot more energy. Okay, that's it for now. That's how you get a starting project with a ball shooting simulator and do a little code work. And we will see you in the next video.